Okay, one other thing we need to learn about logarithms is how to graph them. Now, if you want to graph these by hand, you can, but I would strongly recommend if you're graphing them by hand to rewrite the equation as an exponential first. Because if I'm going to do these by hand, recall that I can rewrite this equation as an exponential by saying my base is 3, and then it's going to be 3 to the x power is going to be equal to y. Basically, to find the inverse, I switch the x and y since they're inverse functions, and then I rewrite it with my base of 3, and I switch places with the x and the y. So that gives me y equals 3 to the x. Now, if I wanted to graph the function y equals 3 to the x, I could make a quick table of values if I wanted to. So x is 0, 1, 2, quick table of values. Y would be anything to the 0 power is 1, which is the usual y-intercept for an exponential function. That has an understood starting value of 1. I plug in a 1, so 3 to the first power is 3. Plug in a 2, it's a 9. So basically I have 0, 1, and then 1, 3, and then 2, 9 would be way up there somewhere. And remember, the shape of an exponential function is something like this with an asymptote. If there is no translation, the asymptote is at y equals 0. So I'll go ahead and sketch my asymptote there. And that's what the exponential looks like. Now, if I want to graph the logarithm, I'm going to switch to a different color. The logarithm, the actual y equals log base 3 of x, remember, inverse graphs, I can switch the x and y to get the graph of the inverse. So instead of 0, 1, 2 on this side, I have 0, 1, 2 on this side. Instead of 1, 3, 9 on that side, I have 1, 3, 9 on that side. Basically, the domain and the range switch. We talked about this a few lessons ago when we did graphing inverses. So that means I have the point 1, 0, which that x-intercept of 1, 0 is a common intercept for a logarithmic function. Then I have the point 3, 1, and then I have the point 9, 2 would be on out there somewhere. So what you end up with is something basically like this, because what used to be a horizontal asymptote of y equals 0 has become a vertical asymptote of x equals 0. So if I'm talking about my logarithmic function, my domain starts at 0, cannot touch 0 because it's an asymptote, so that's a parenthesis, and it goes to infinity. My range, on the other hand, is all real numbers because you can see that thing goes all the way down off the bottom and all the way to the top. Now, just for a way of comparison, for my original function, my domain, my exponential function, my domain would have been all real numbers. And my range of my exponential function would have started at 0, couldn't have been 0 because there was an asymptote there, and gone to infinity. So basically, notice once again that what used to be the range of your exponential, the domain of your exponential has become the range of your logarithm, and the range of your the range of your exponential has become the domain of your logarithm. They've basically switched places because finding the inverse function, I switch all of my x and y values. Now, of course, you can always do these in Desmos to test, and we'll go over that on the next video, how you can get these answers with Desmos, but I just wanted to show you how to do it algebraically, and we'll practice a little bit more both ways on the next video.